Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak Nemani and this is Daily Quant with Deepak. Hi all, welcome back to day 97 of 100 days to CAT Quant series. In this video, we'll be discussing 5 questions from Quant. So whenever a question is displayed on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. If you find this video helpful, like the video, share this video with your friends who are preparing for CAT, and most importantly, for more videos of this kind, subscribe to this channel. In case if you want to attempt these 5 questions in the form of a test, you can log into our portal, the gurukul.org.in. The link is already in the description. Now once you log in, you'll get access to a course called 100 days race to CAT, in which there will be 3 sections: Quant, LRD and VRC, with 100 tests each. So on a whole, you'll be practicing 300 tests, which is close to approximately 1500 questions, right, which we consider to be a good number of questions in the last stage of your preparation. And these tests are absolutely for free. And without any further delay, let's get started with the first question. Now coming to the first question, f of x is a quadratic polynomial such that f of 1 is equal to f of minus 2 and x minus 5 is a factor of f of x. Which of the following is another factor of f of x? Now given that f of x is a quadratic polynomial, I can say f of x will be in the form of ax square plus bx plus c. And we are given with f of 1 is equal to f of minus 2. So let me substitute the value of x as 1. So this becomes a plus b plus c should be equal to, now let me replace x with a minus 2, 4a minus 2b plus c. Now I can cancel these two, right? Now bringing minus 2b to left hand side, we'll be having 3b is equal to 4a minus a, 3a, which gives us a is equal to b. Now the quadratic polynomial f of x should be in the form of ax square plus ax plus, and now we are also given that x minus 5 is a factor of f of x. Now if x minus 5 is a factor of f of x, if I replace x with 5, f of x, the value of f of x has to be 0, right? So then, 25a plus 5a plus c should be equal to 0. So c is nothing but minus 30a. So f of x looks like ax square plus ax minus 30a is equal to 0. So this would be a into x plus 6 into x minus 5 is equal to 0. Now x minus 5 is a factor of f of x. Yes. Now what was asked? What is the which of the following is the another factor of f of x? It has to be x plus 6. Hence option D becomes the answer to this question. Now coming to the second question, find the second smallest natural number that has exactly 10 factors. Now if we have any number in the form of a power p into b power q into c power r, given that a, b and c are prime, then total number of factors would be p plus 1 into q plus 1 into r plus 1 and so on. Right? Now here in this question we are given with the total number of factors being 10, right? So 10 will be equal to p plus 1 into q plus 1 into r plus 1 and so on. Now first let's try to factorize 10. Now how can I factorize 10? 10 can be written as 1 into 10 or 2 into 5. Now if I consider 1 into 10, now compare 1 into 10 with p plus 1 into q plus 1. So what is the value of p? 0. What is the value of q? 9. Right. So that number should be in the form of a power 9. Right. So if we have any number in the form of a power 9, a being prime, the total number of factors would be 10. Right. And if I consider 10 as 2 into 5, compare it with p plus 1 and q plus 1. Right. So value of p is 1 and value of q is 4. So if you have a number in the form of a into b power 4, then also the total number of factors is 10, right? Now what is the least number which is in the form of a power 9? 2 power 9, right? Now least number which is in the form of a into b power 4, right? So let us have minimum value for b, right, and the next minimum value for a, right? So that would be 3 into 2 power 4. Now I can say that 3 into 2 power 4 is less than 2 power 9. Now if 3 into 2 power 4, the smallest, so the next smallest number would be, now let me put 2 power 4 only. Let this remain the same, because if I increase the value of b, the number increases. Right. Now let's increase the value of a. What is the next highest value of a? 5. So 5 into 2 power 4 becomes the second smallest number, and the smallest being 3 into 2 power 4. Now what is the value of 5 into 2 power 4? 2 power 4 is 16. 16 into 5, 80 should be the answer to this question. Now coming to the third question. The number of integers greater than 3000 with no repeated digits that can be formed with digits 0, 1, 3, 5, 7, 8 and 9. Right. So how many digits do we have? 7 digits. Right. So we can form a 4-digit number. Right. Greater than 3000, we can form a 5-digit number, 6 and 7-digit number as well. Right. So let us find the total number of 4-digit numbers. Right. So greater than 3000. So you can have either 3 or 5 or 7 or 8 or 9 in a thousands place. So 5 into, now if you have 3, 5, 7, 8, 9, any of these 5, right, in the thousands place, that number will be greater than 3000 for sure. Right. So you can select the other number in 6 ways, 5 ways and 4 ways. Right. So 5 into 6, 30, 30 into 20, 600. Then coming to 5-digit numbers, 1, 2, 3, 4, 5. Now any 5-digit number will be greater than 3000. Right. So let us see how many 5-digit numbers can be formed using these 7 digits. Right. So you can select this digit in 6 ways, because this you cannot include 0. Then you can select this in 6, 5, 4 into 3. Right. Now this is 5-digit numbers. Right. So coming to 6-digit numbers. So the number of 6-digit numbers that could be formed would be again 6 into 6 into 5, 4, 3 into 2. And finally the 7-digit numbers. So 6 into 6 into 5 into 4 into 3 into 2 into 1. Right. So the sum of all these numbers will give us the answer to this question. Now coming to the next question. An inlet pipe connected with a tank starts filling the empty tank, but it develops a leakage after some time. As a result, the flow reduces to 60% of its normal capacity and the tank becomes full at 5:30 p.m. Had the leakage started after filling additional 90 liters of water, the tank would have been filled completely at 5 p.m. Find the rate at which the inlet pipe fills the tank when working at its full capacity. Right, now let the full capacity of the pipe be x. Right, now because of leakage, the flow reduces to 60% of the normal capacity, so 0.6x. Now because of this, the tank becomes full at 5:30 p.m. Had the leakage started after filling additional 90 liters of water, the tank would have been filled completely at 5. Right, so there would be a 30 minutes delay. Then if you have these 90 liters filling at this usual capacity, the full capacity, and filling at 60% of its full capacity. Right. Now, because of these 90 liters being filled at 60% of its capacity, instead of 90 liters being filled at its full capacity, there is a difference of 30 minutes. Right. So, what would be the time taken to fill these 90 liters at 60% of its capacity? 90 by 0.6x minus 90 by its full capacity x. This is equal to 30 minutes. Right. Now what was asked? Liters per minute only. So it has to be in minutes. Now what is 90 by 0.6? That would be 150 by x minus 90 by x is equal to 30. Now what is 150 minus 90? 60 by x is equal to 30, or this implies x is equal to 60 by 30, which is nothing but 2 liters per minute. Right. So the answer to this question should be option A. Now coming to the last question. Two ships are approaching a port along straight routes at constant speeds. Initially, the two ships and the port formed an isosceles right angle triangle. Okay, so we have an isosceles right angle triangle with the slower ship being closer to the port, right? So this cannot be the port. If this is the port, both the ships will be at same distance from the port, right? Now since it is given that the slower ship being close to the port and 60 kilometers from it, now if I consider this to be a port, now this should be the slower ship, right, which is at 60 kilometers, right? So if this is 60 kilometers and let this be the faster ship, now the distance between port and the faster ship should be 60 root 2, right? Now when slower ship traveled 30 kilometers again, so exactly at the midpoint, the three formed an isosceles triangle, but this time the faster ship was closer to the port, right? So again an isosceles right angle triangle is formed. Now this faster ship is closer to the port, right? So if that's the case, this would be 30. Now if hypotenuse is 30, now this should be 30 by root 2, right? So 30 by root 2 is nothing but 15 root 2. Done. Then what? Now when the faster ship reaches the port, the distance in kilometers between the slower ship and the port would be, right? So if this distance is 15 root 2, what is the distance traveled by the faster ship? 60 root 2 minus 15 root 2, which is nothing but 45 root 2. Now in the time that the faster ship traveled 45 root 2, what is the distance traveled by the slower ship? 30, right? So in the time that the faster ship travels 45 root 2 kilometers, the slower ship travels 30 kilometers. Now if the faster ship travels 15 root 2 kilometers, then the slower ship will be traveling one third of this, because 15 root 2 is one third of 45 root 2. Now this should be one third of 30, which is nothing but 10, right? So by the time the faster ship reaches the port, right, slower ship will be traveling for another 10 kilometers. So the total distance would be 40, right? Now what was asked, right, at that time what is the distance between slower ship and the port, right? So 60 minus 40, 20 kilometers should be the answer to this question.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, study room to boardroom, the entire playlist, click here.
If you learned from today's session, like, share, and subscribe.